Hello, I'm Gregor Köhler from the Division of Medical Image Computing at the German Cancer Research Center in Heidelberg. And with this work, we want to show that it might be worth to recycle your latent representations. The title of the paper is RecycleNet, Latent Feature Recycling Leads to Iterative Decision Refinement. First, for some background and motivation. What we see is that many errors in predictions of neural networks are quite obvious and evident upon review, and we think that these could easily be refined. And we humans also often tend to iteratively adjust our initial guesses. So in this work we asked ourselves, can we instill such capabilities into our model in a simple and straightforward way? To achieve this, we propose to increase the number of forward passes through a part of the network referred to as the recycling module R. Here the latent representations of a later stage of the network are normalized and fed back into an earlier stage for a number of cycles, while only using gradients from the last forward pass. In this simple form, the only requirement is to have matching latent dimensionalities in two parts of the network. To showcase our method, we rely on the NN-unit framework, which implements a range of units and is widely used in the medical image segmentation community. The framework automatically adapts architectures and preprocessing, etc. to a given dataset and delivers state-of-the-art performance across many datasets. In terms of datasets and benchmarks used in this work, we focus on kidney tumor segmentation, on CT images, as well as abdominal organ segmentation on MRI and CT. Jumping to the results on the abdominal organ segmentation dataset, in this case showcasing the average dice score on a 5-fold cross-validation over the number of cycles during inference. And what we see here is that indeed the proposed feature recycling brings iterative decision refinement capabilities, improving the performance even over this strong baseline. And also what we see is that performance increase is ongoing beyond the number of cycles seen during training, which in this case was to a maximum of 3 cycles. We can also see the iterative decision refinement capabilities when we showcase the contours of the segmentation maps over a number of cycles during inference. In this case cropped to 2 examples, and what we see is that over the number of cycles we move closer and closer to the contour of the given ground truth. And this iterative refinement translates to improved segmentation performance, even compared with the strong baseline that is NN-unit on a range of datasets, tasks, and modalities. And we improve the segmentation performance over NN-unit in all but 1 task, and we also outperform the recurrent unit while not requiring any changes to the network architecture, and also having significantly lower memory demands for the proposed method. When we take a closer look at the memory demands during training, we see that RecycleNet does indeed incur a small memory overhead, which however remains constant irrespective of the number of cycles used during training, while the recurrent alternative comes with prohibitive memory demands, especially in the context of 3D image segmentation. We also performed an ablation study concerning the different strategies for the recycling schedule in training. And we see that a number of different schedules perform well and improve on the baseline. However, the most robust strategy comes from sampling from an increasing range of. So as best practice, we recommend having a warm-up period of just using one forward pass, so no recycling, and then sampling from an increasing range of possible number of cycles. So in conclusion, we propose RecycleNet, which is a simple method to instill iterative refinement in existing architectures. And we show that this iterative refinement yields improvements even over strong baselines, as showcased in the example of medical image segmentation. And given the simplicity and minimal assumptions this method has, this is by no means restricted to the medical segmentation domain, so it might be worthwhile to also recycle your latents.